is the definition for parity. Definition 17. The statement that the integer n is even means there's an integer q such that n equals 2q, period. The statement that the integer n is odd means there is a q element of z such that n equals 2q plus 1, period. Now the definition for the well-ordering principle is axiom 17. Suppose big S is a subset of Z plus, period. Then big S has a least element, period. Parentheses. A set big S has a least element if there exists an element, big S, such that for any x element big S, comma, then n is less than or equal to x, period, parentheses. Okay. Now this is for mathematical induction. Okay. So the theorem, so this following theorem is known as the induction theorem or the principle of mathematical induction, period. Condition 1 is called the base case, comma, while condition 2 is called the inductive step, period. We can use mathematical induction to prove theorems as well. Okay, so this theorem is called the weak theorem. Okay. So basically the theorem I'm about to say is the mathematical induction. Okay. Oh my gosh. Suppose big S is a subset of Z plus satisfying the following conditions. Semicolon. I. So the first condition is I. 1 is an element of big S. Double I. If 1, 2, dot, n is an element of big S, then n plus 1 is an element of big S. Okay, next line. Then, okay, now this is like next line. It says then S, big S contains all of the integers, all of the positive integers. In other words, or parentheses, in other words, comma, big S equals Z plus, parentheses. Okay, now these are the definitions for equivalence relations. Definition 20. A relation, comma, big R, comma, on a set A is a collection of ordered pairs, comma, parentheses, little a, comma, little b, parentheses, comma, such that a, comma, little b, element, big A, period. Definition 21. A relation, comma, big R, comma, on set A is reflexive if upside down A, little a, element, big A, we have A, big R, and then we have little a and then big R and little a. Definition 22. A relation, comma, R, big R, comma, on a set, big A, is symmetric if whenever little a, comma, little b are elements of big A. With A, big R, B, then we must have little b, big R, A. Definition 23. A relation, comma, big R, comma, on a set A, big A, is transitive if whenever little a, comma, little b, comma, little c, element big A with little a, big R, little b, and little b, big R, little c, comma, then we must have a, big R, little c. Definition 24. A relation big R on a set big A is called an equivalence relation if it is reflexive, comma, symmetric, comma, and transitive. Definition 25. If big R is an equivalence relation on a set big A, comma, and little a is element big A, comma, we define the equivalence class of little a to be the set of all elements in A that are related to A. That's it.